Okay, first we're going to talk about monomials versus polynomials. A monomial is a term with variables, numbers, and or exponents that are all together. No plus or minus signs. Example, 2x. Another example, 4xy squared. Another example, 10x squared y cubed. So these are all monomials because there are no plus or minus signs in between the variables or the coefficients. No plus or minus signs, no plus or minus signs. Now a polynomial, poly means many. So it's going to have two or more monomials added or subtracted together. So for example, if I have 2x, right now that is a monomial because it has one term. Monomial means 1. So if I want to add 2 or more terms, I'm just going to plus or minus something else. So I can just make up anything. Put a 3 there. Now it has 2 terms. 2x is one term, 3 is one term. If I want to take 4xy squared and make it into a polynomial, I could add on or subtract on something else. I can add on an x squared. I can add on another term, plus 3xy. It has 1, 2, 3 terms. Same thing with this example. If I wanted to make it into a polynomial, I could just add on another term. So why don't you go ahead and add on another term here. It could be anything. Okay, degrees of a polynomial. The greatest degree term in a polynomial. So the degree is the greatest exponent of that term. So on number 1, it is a polynomial because it has 2 terms. Here's one term, here's another term. Terms are separated by either a plus or a minus. So look at the exponent for the first term. It doesn't have one, so the exponent is 1. So this has a degree of 1 because that's the largest exponent. This one has a degree of 5 because 5 is the largest exponent. So which term has the largest degree, the greatest degree? The greatest degree is 5. So if I was to ask, find the degree or what is the degree of this polynomial, you would say 5 because 5 is the largest exponent. Okay, so number 2, I'm going to look at the variables. Here I have an exponent of 2 for the x. For the y, it has an exponent of 1. So whenever you have more than one variable in one term, you add those two exponents together to get one combined degree. So 2 plus 1 is 3. So this term has a degree of 3. The second term, I have x and y. They both have an exponent of 1. So I'm going to combine those exponents together to get a degree of 2. Third term, it has no variables at all. So whenever you have a term that has no variables, it's called a constant. For constants, they always have a degree of 0. So which term has the largest degree? 3. So this one will be a degree of 3. Try 3 and 4 on your own. Okay, let's go up to standard form. A polynomial is written in standard form when the degrees are in descending order. Rewrite the following in standard form. State the degree and the leading coefficient. So I have 3 terms. This term has a degree of 0 because there's no variable, there's no exponent. This term has a degree of 2. This term, the exponent is 1, so it has a degree of 1. So I'm going to write them in descending order. That means you're going to start with the highest exponent, the highest degree, and then you're going to go to the next highest degree and the next highest degree. So this one goes first because it's degree of 2, then the degree 1 goes, and then the degree of 0 goes. Okay, same thing with this one. This one has a degree of 1. This one has a degree of 2. This one has a degree of 3. So, which one goes first? Degree of 3. Next, degree of 2. So make sure you take the sign with it when you copy it down. It has to be a minus 9x squared. Then the degree of 1 goes. So what symbol are you going to put here, a plus or a minus? Well, since this had this was a positive 4, you need to make sure you put the plus 4. Do C on your own. Naming polynomials. So polynomials have a first name and a last name. The first name depends on the degree of the polynomial. The last name depends on how many chunks or how many terms the polynomial has. So if it has 1 term, it's a monomial, because mono means 1. 2 is a binomial. Bi means 2. 3, can you guess it? It's a trinomial. 4 is a polynomial. 4 or more is a polynomial. Anything beyond 4, you call it a polynomial. Okay, so the first name is how many degrees. Depends on the degrees. If it has 0 degrees, that's called a constant. That means you have no variables, you just have a number. 1 is linear. 2 is quadratic. 3 is cubic. 4 is quartic. 5 is quintic. 6 is sextic, or it could also be hexic. Okay, adding polynomials. Parentheses do not change the problem. Combine like terms. Exponents do not change. Okay, so I have 7x cubed. Now, the x cubed is very important. Do you see any other x cubed? No. Keyword is to combine like terms. If they are not like, you cannot combine them. So since there are no more x cubes, I cannot combine that with anything. So I keep it. Okay, cross that out because I already used it. Now I'm going to deal with the x squares. Do I have any other x squares? You have 1 right here. So you're going to combine 6 plus 9. $15x squared. Cross them out, I've already used them. And then you have the x. You have another x term here. So I have -2 plus -4. It's going to be -6x. Now the only thing I have left is this 3. So I just keep +3. And that is your answer. Try the second example on your own. Okay, subtracting polynomials. Watch out for minus signs and negatives. Highlight or circle the subtraction signs between each pair of parentheses. Okay, so subtracting is very similar to when we added the polynomials, except for you have parentheses here. So the negative changes everything after the parentheses. So basically every sign changes. So this will become a -9. This will become a +4. This will become a -3. So when you have that negative, every sign after the parentheses changes. So I have 7x cubed. I don't have any x cubed, so I just copy them. Done with that term. 6x squared and -9x squared. So you subtract 6 minus 9, -3x squared. Now the x term. Make sure when you circle these, you circle the sign that goes with it. So this is a -2x, and this is a +4x. So 2x plus 4x is -2x plus 4x is a +2x. And the last one I have is a -3 because that changed. Okay, try the last example on your own. When you're done with these, glue them in your notebooks.